I'm going to go through the answers to an open book quiz for a 10 Maths Methods quiz that was done in last week in May, so a summary of the semester work that we've been looking at. So the first one we have is adding algebraic fractions. So when we're adding or subtracting fractions, we need to have the same denominator. So looking at the denominators here, we've got 5 and 2. They both go into 10. So the 5 has been multiplied by 2 to get to 10, which means our 3 needs to be multiplied by 2, which will give us 6. Our 2 has been multiplied by 5, so our a needs to be multiplied by 5, and we will get a 5a there. Part B is multiplying. So when we're multiplying fractions, we want to do top times top and bottom times bottom. When we see an expression as part of the fraction, we want to make sure that is factorized as much as possible. So here we've got 3x minus 3. We can make that 3 outside of x minus 1 times 7. And then on the bottom we'll have 28 times x minus 1. We're then able to cancel out that bracket because we've got it multiplied on the top and on the bottom, which leaves us with 21 on 28, which we can then simplify as 3 over 4. In the next one, we're doing a solving question. So we're going to expand out those brackets first and then start solving. So when we expand 3 times 2x, we get 6x. 3 times 1 is 3. Negative 2 times x is negative 2x. Negative 2 times 5 is minus 10. And then we've got plus 7. We want to simplify that here. Negative 10 plus 7 is going to give us negative 3. And so now I want to solve the equation. So I might start by, we've got a few options. I'm thinking I might add the 3 to start with, since I've got a minus 3. That's going to leave me with 6x plus 6 is equal to negative 2x. Then I'm going to, I'll need to take the x's to the one side, so I'm going to do take away 6x here. And I get 6 is equal to negative 8x. So then to get the x on its own, I'll do 6 divided by negative 8, which gives me negative 3 on 4 when I simplify that. Obviously there are other options. Up here you could have taken away 3 to start with or added the 2x to start with. You'll still end up with the same answer if you follow that through. Writing the equation of a line with a gradient of 3 and a y-intercept of negative 5. So we've got our y equals mx plus c for our linear equations. So our y is equal to 3x take away 5. Finding the length and midpoint between 2 points. So our midpoint is our x1 plus x2 over 2 and y1 plus y2 over 2. So we have 2 plus 6 over 2 and 5 plus 11 over 2. 2 plus 6 is 8, divided by 2 is 4. 5 plus 11 is 16, divided by 2 is 8. So our midpoint is 4, 8. Then for our distance, we want to do d is equal to the square root of y2 minus y1 squared plus x2 minus x1 squared. So we've got the square root of 11 take 5 squared plus 6 take 2 squared. 11 take 5 is 6, so 6 squared is 36. 6 take 2 is 4, 4 squared is 16. So then we get the square root of 52. And we can pop that into our calculator to get a decimal answer, or we could simplify using our surds. If we do the decimal, we get 7.211. So then we've got the next one is simultaneous solutions. Now in this case we've got a y on its own, so it's going to be substitution. So where we see a y in the second one, we're going to put the 2x minus 5. So we'll have 3x take away 2 outside of 2x take 5 is equal to 18. That means we will have 2 times 2x is 4x, and then that will become plus 10. 2 times negative 5 is negative 10. We're taking it away, so it becomes plus 10. So then we're going to simplify that to negative x plus 10 is equal to 18. Then we're going to take 10 from both sides. Negative x is equal to 8. Therefore x is equal to negative 8. Then we'll sub that back into our y equals 2x take 5. If we've got negative 8, 2 times negative 8 take 5. So we get negative 16 take away 5 gives us negative 21 for our y value. On to the next page, we're going to do some simplifying of surds. So we've got 4 root 200, so we can write that as 4 times the square root of 100 times the square root of 2, because we can break the 200 into square root of 100 and square root of 2. Square root of 100 is 10, so we have 4 times 10 root 2, which is 40 root 2. Here we've got 2 root 3 times 3 root 15, so the 2 times 3 is 6. Root 3 times root 15 will be root 45. Then we have to look at the 45 and say, well, we know that 9 will go into that, so you'll have root 9 root 5. The square root of 9 is 3, so 6 times 3 is 18, root 5 is our answer there. When we're rationalising it, it means we don't want a surd on the bottom, on the denominator, so we need to multiply the top and the bottom by root 3. So we end up with 2 root 3 over 3, because root 3 times root 3 gives us 3. Here we've got an index laws question, so I'm going to write it and in its fraction form first. And that sometimes helps us with our simplifying. So the 4 over 8 means we're going to have 1 over 2, x squared and x, so we'll have an x left on the top. Y to the 5 and y to the 2, we've got more on the top, so it'll be y to the power 3. So we can write that as xy cubed over 2 as well. Here we've got using our 0 index, so 2 times p to the 0, so that'll be 2 times 1. Anything in the bracket raised to the power 0 is going to give us 1 then, so we get 2 plus 1 is equal to 3. Writing with our positive indices, if they've got a negative index, it needs to go to the bottom to become positive. So we've got our 3 and our z are going to stay on the top, and then the x and the y are going to go to the bottom, so the negative 2 will become positive 2, and the y will become positive 4. Solving for x, we want to change these to powers of prime. So we have 5 squared raised to a power x is going to equal 5 cubed. That means we can write that as 5 to the 2x is 5 to the 3. Then we can say that that means that the 2x must be equal to the 3. So x must be equal to 3 over 2, or 1.5. Okay, question 13 is using just our basic trig ratios, so the sine, cos and tan. So we're labelling with our AOH to start with. We've got AOH, here we've got AOH, and here we've got AOH. So for this one here, we've got the A and the H, which means it's going to be cos. Here we've got an O and a H, so it's going to be sine. And in this one we've got an A and an O, so it's going to be tan. So looking at the first one, we're putting in what we know. So cos 30 is going to equal 5 over x. If the x is on the bottom, that means they swap sides. So x is equal to 5 on cos 30. So we grab our calculator, making sure we're in degrees. And we get 5.77, and that is meters. Then here we've got sine of 40 is equal to x over 5. Our 5 is on the bottom, that means we'll multiply. So we're going to do 5 sine 40, and we get 3.21. I'll round that to 4. Then the last one we've got is our tan one, where we have our angle that we're trying to find out. So we have tan of x is equal to our 7 over 4. So then to get the x, we'll just do tan to the negative 1 of 7 on 4. So I'm going to pop that into my calculator. So that's the second tan when we do that. 7 over 4. And we get 60.255. degrees for that one. Okay, then we get on to some Pythagoras theorem questions. So we've got c squared equals a squared plus b squared. So in this case we've got a, b, c. So we've got our x squared is going to equal our a squared plus b squared, which in this case is 12 squared plus 11 squared. When we do our 12 squared plus 11 squared, we get 265. When we do the square root of that, we get 16.27, and that will be meters, which I'll round to 16.28 to decimal places. Over here, we're going to get our 20 squared is equal to our x squared plus 8 squared. So then to get the x squared on its own, we're going to do 20 squared take 8 squared. When we do 20 squared take 8 squared, we get 336, and the square root of that is equal to 18.33. And that is centimetres in that case. Having a look at question 15, which is looking at bearings. Now bearings we always want as a 3-digit number from north around to the line. So for A, we're wanting to know what that angle is there. We know that this part is 90, so this must be 50. So for A, it's going to be 050 degrees because we want it as a 3-digit number. Then when we go on to our B, we want this angle all the way around here. So we know we've gone 90 plus another 50. So for B, 90 plus 50 gives us 140 degrees. Then for C, we're going all the way around here to that line. We're almost at 270, but we haven't gotten there. We're 30 degrees away. So for C, we're going to do 270 minus the 30 because we haven't done the full 270. 270 minus 230 is 240 degrees. And then our last one, D, we're going all the way around, almost the full circle, bar 20 degrees. So for D, it's going to equal 360 minus that 20 degrees, so it's 340 degrees for that one. Question 16. A ship travels due south for 5 kilometres and then on a bearing of 120 degrees for 11 kilometres. Find how far south it is from its starting point. So we're drawing a diagram. So we've got it going down 5 kilometres and then it goes on 120 degrees. So that angle there is 120 degrees for 11 kilometres. And so we want to find out how far south it is from its starting point. So we can make a triangle here because we're looking for those right angle triangles that we can make. We know that this part must be 60 degrees to make that 180. So our triangle becomes 60 degrees there, 11 kilometres, and we can find out the x. So labelling that with AOH, we know we're using cos. So cos of 60 is going to equal x over 11. So 11 cos 60 is going to give us our x. And we get 5.5 kilometres. Now we want the total distance south, and we know it already travelled 5, and then another 5.5. So the total is going to equal 5 plus 5.5, which is 10.5 kilometres. Then we've got a volume of a cone. So our volume of a cone is 1/3 of pi r squared times the height. So we've got 1/3 times pi times 11.5 squared times 29. Always check that your units are the same for your height and your radius. So I'm going to type that straight into my calculator. I'm going to put the 1/3 times pi times 11.5 squared times 29, and I get 4016.26 millimetres cubed. And then over here I've got a sphere, and my volume of a sphere is 4/3 pi r cubed, and I've been told a radius of 7. So I've got 4/3 pi times 7 cubed. Oops. So 4/3 times pi times 7, and I put squared and it changed it to cubed. I should have done my up arrow one there. And I get 1436.75, and I'll round that to 76 centimetres cubed. Now if I wanted to do that 7 cubed rather than doing the squared like I accidentally did, I can do my 7 up arrow 3 and type that index in there. Then I get onto some more triangle questions. These are non-right angle triangle questions, so I'm using my sine and cosine rules here. Here I've got the 7 and its matching angle, so I know I'm using the sine rule. So I can make that sine A, B, B there. So I've got A on sine A is equal to B on sine B. I've got 7 on sine of 75 is equal to X on sine of 80. So to get the X on its own, I'm just going to do sine of 80 times by 7 over sine of 75. I can put that straight into my calculator. I'll do the 7 divided by sine of 75 first, then I'll times that by sine of 80, and I get 7.136. That I'll round to 7.137 because the 8 is next to that, and that is meters. Then over here I don't have a side and its matching angle, so I'm going to use the cosine rule. So I've got C, my big C, A and B. So I've got C squared is equal to A squared plus B squared minus 2AB cos C. Then I'm going to put in what I know. So I've got my 8 squared plus 6 squared minus 2 times 8 times 6 cos of 40. So I'll do my 8 squared plus 6 squared, and I get 100. And I'm going to take away 2 times 8 times 6 cos 40, which is 73.54. So I'll do my 100, take away that answer, gives me 26.4597. That's what my C squared is. So to get my C, I'll do the square root of that, and I get 5.1439. I'll round that to 5.144, and that is centimeters. Finding the area, I'm going to use my area is equal to a half AB sine C. So I've got a half times 11 times 13 times sine of 42. And I get 47.84, and that is meters squared. And my last one is finding some exact values. So I've got 150 degrees and I've got sine of 150 and cos of 150. So looking at my quadrants, 150 is in the second quadrant. It is 30 degrees away from that horizontal. So I know that that's going to equal sine of 30 degrees, because in that quadrant sine is positive. And my cos 150 is going to equal negative cos of 30 degrees. Now to get those exact values, I can use my 30-60 triangle, which means for sine it's going to be for 30 opposite over hypotenuse, which will be 1 over 2. For cos it's going to be adjacent over hypotenuse, so it'll be negative root 3 on 2. So I get my negative from what quadrant it's in. It's in the second quadrant, so the sine is positive, the cos is negative, and then I can go to my exact value triangle to work out the values for that.